Prior to this lesson, you should have learned how to take any trinomial in the form of ax squared plus bx plus c and turn it into two binomials using the process of factoring. Today, we're going to use the process of factoring to now solve for possible values of x for a quadratic equation rather than just a quadratic expression, which we've learned is called a polynomial. In order to use this process, we need to first, if necessary, rewrite the equation into standard form. So when we're writing the equation in standard form, you have to make sure that the x squared term comes first, the x term is in the center, and the constant or the c term is out at the end. Second, you're going to factor the quadratic equation using the process of grouping. Third, you're going to set each factor containing a variable equal to 0. Fourth, you're going to solve each of the resulting equations. And number 5, you're going to check by substituting each value of the variable in the original equation. The checking process is not always necessary, but if you feel like you possibly made a mistake, it wouldn't hurt to plug it back in to be sure that you did it correctly. So for example, number 1, we see that it is not written in standard form, so that needs to be our first step. So in this case, we're going to add 10 to both sides to get the equation equal to 0. Which gives us x squared minus 7x plus 10 equals 0. Now we want to find our factors of 10 that have a sum of -7, and that obviously is -5 and -2, and do our grouping process. So we have x squared minus 5x minus 2x plus 10 equals 0. Now I could have switched around the -5 and the -2. It would not have made a difference in my answer in the end. Now I'm going to group. In the first set, I can take out x. That is a common factor. So I have x times x minus 5. In the second set, I'm going to take out -2. My goal to get the second set of parentheses equivalent to my first set of parentheses, -2 times x gives me -2x. -2 times -5 gives me +10 equals 0. My common factor that I can factor out is x minus 5. My second factor is x minus 2 equals 0. From here, I'm going to set both those parentheses equal to 0. So x minus 5 can equal 0, or x minus 2 can equal 0. And I'm going to solve each of those, plus 5, plus 5. So x can equal 5, plus 2, plus 2. So x can equal 2. Therefore, my two possible solutions for this first equation are x equals 5 or x equals 2. And if I plug them into my original equation, they should both check. 5 squared is 25, 7 times 5 is 35, and 25 minus 35 is -10. If I plug in 2, 2 squared is 4, and 7 times 2 is 14. 4 minus 14 is -10, so we did it correctly. For number 2, we're going to go through the same process. Again, it's not written in standard form, so to get it written in standard form, I'm going to add 2 to both sides of the equal sign. This gives me x squared minus 3x plus 2 equals 0. Now I'm going to go through my factoring process. I know my product is 1 times 2, which is 2. I need the factors of 2 that have a sum of -3, and that would be -2 and -1. Now I start replacing the -3 with -2 and -1. So we have x squared minus 2x minus 1x plus 2 equals 0. And again, if I reverse the -2 and -1, it would not have made a difference in my final answer. I can group the first 2 together and the second 2 together and factor. X squared minus 2x has a common factor of x. X times x minus 2 gives me x squared minus 2x. -1x and +2, I can factor out -1, because again, my goal is to get the first set of parentheses again. -1 times x is x. -1 times -2 is +2. Common factor is x minus 2. Second factor is x minus 1 equals 0. Then my next step again is to set each of those parts equal to 0. So x minus 2 equals 0, or x minus 1 equals 0. I can add 2 and add 2. I get x equals 2. I can add 1 and add 1, and x equals 1. So my two solutions for this quadratic equation is 2 and positive 1. So now I can plug those in just to double check. 2 squared is 4, and negative 3 times 2 is negative 6. 4 minus 6 is negative 2. If I plug in 1, 1 squared is 1, and 3 times 1 is 3. 1 minus 3 is negative 2. We did it correctly. So you're on your own for 3, 4, 5, and 6. Go ahead and work on those, and then tune back in for examples 7 and 8.